This is the second to last question in the paper, and I've got to say, it's a nice one. It takes a bit of time, and that's the main frustration, but it's something you should have done many, many times, finding the inverse of the matrix when by hand, basically. We have to here because there's a k in there, we can't put it in our calculator. So remember, the inverse matrix is equal to 1 over the determinant of your matrix multiplied by the cofactor matrix transposed. And we're going to deal with this one at a time. So let's get the determinant of A. And I'm not going to into loads of detail where these things come from. We just need to kind of accept them at this point, and just expand carefully to like get each of the things. So the determinant of A, I'm going to expand along this row. You don't actually have to use this row. You can use other ones, but there doesn't really seem any advantage to using anything else here. So it will be equal to 3 times the determinant. Remember, you then cross this out. I'm dealing with the left one. We're going to get 1136. The next one is minus 1, and then the determinant of 11k6. Because it's always minus 1 to the power of the row plus the column. So we get a minus 1 here. You get a minus 1 here as well, for example. We'll deal with that in a minute when we deal with the cofactor matrix. And then it'll be plus, but minus 1, and then 11k3. That is our determinant. So we expand it and get these like 2 by 2 determinants. Okay, so now I'm going to do 3 times, it's going to be 6 minus 3, so that's 3 times 3, minus 6 minus k, and then minus 3 minus k. That's 9 minus 6 plus k minus 3 plus k, and our determinant is 2k. Got that bit sorted. By the way, we need the determinant to be non-zero to get an inverse, and it will be here because k is non-zero. Onto the cofactor matrix then. Similar kind of approach. So what we do is we construct our matrix of minors first of all, and this is essentially the same idea as when we found the determinant. We're going to get, like for the 3, now we just ignore the 3, but we're going to get the determinant 1136. Now I did work that out a minute ago, but I'm going to do it again. And then we'll work our way along. I've just realized I've not made this anywhere near as big enough as I need to. So then I will get 11k6. This is just like before. And 11k3. So that's the matrix of minus part. For the cofactor matrix, we're going to be bringing in a minus here. Because remember, again, it's minus 1 to the power of the row plus the column. So I'm going to get minuses here, here, and here. Sometimes people draw a little matrix to help themselves. It's going to be plus, minus, plus, minus, plus, minus, and then plus, minus, plus. Okay, let's keep going. So now I'm going to remove this. I've got 1 minus 1, 3, 6. And then 3 minus 1, k6. Then 3, 1, k3. Take it steady. Then 1 minus 1, 1, 1. And it's minus 3 minus 1, 1, 1. And lastly, 3, 1, 1, 1. Okay, good. And let's figure this out. We're going to get 6 minus 3, 3. We're going to get 6 minus k, but then made minus. It's going to become k minus 6. If you want to put extra steps in, then go for it. 3 minus k. Then 6 minus minus 3, that's 9, but then made minus, that's minus 9. 9 minus minus k, that's going to be 9 plus, no, sorry, 18 plus k. 9 minus k, but then made negative, so k minus 9. 1 minus minus 1, so 2. 4 plus 1, that's going to be, no, wait, hold on, sorry, 3 plus 1. It's so easy to make a mistake here, but then made minus, going to be minus 4. And 3 minus 1, 2. All right, and we're basically there. The inverse matrix is going to be 1 over 2k, 1 over the determinant, but then I'm going to be multiplying not by the cofactor matrix, but by the cofactor matrix transposed. And remember, what that means is that we are reflecting along this diagonal. So I'm going to get 3 as before, but then it's going to become minus 9, k minus 6. This is something you, of course, you just learn this, but you should see where it comes from by playing around with simultaneous equations. Whenever I teach this topic, I go into quite some depth on where it comes from. I don't go to like the levels of university mathematics where you can kind of show it a bit more easily, but it is good to see the origins of it, and for 2 by 2 as well. I'm not going to do it here, it's pretty involved. 18 plus k, and then this is swapping around, so we're going to get 2 and 3 minus k, k minus 9 minus 4 and 2. And that is our inverse matrix. No need to multiply through by like 1 over 2k, just leave it like this. Okay, on to part B. Determine in simplest form, in terms of k, the coordinates of the point where the following planes intersect. So 3 planes given by these equations. Now we can write them in matrix form. We're going to get 3, 1, minus 1 multiplied by x, y, z equal to 3. That's that first equation written down. When you expand it out, you'll get back to that first equation. Then 1, 1, 1, and 1. And k, 3, 6, and 6. And this matrix here is actually the same as A. What that means is x, y, z, what we can do is pre-multiply through by the inverse. So we'll just get the identity on the left and then the x, y, z. So we just get x, y, z is equal to the inverse matrix multiplied by 3, 1, 6. Okay, and we've got our inverse matrix here. So it's going to equal this multiplied by 3, 1, 6. Keep the 1 over 2k out of it for the moment. And then let's multiply the matrices. Okay, remember I'm going along and down. I'm going to get 9 minus 9 plus 12. It's going to give me 12. Then, okay, I'm going to write this one out in full. I'm going to get 3k minus 18 plus 18 plus k minus 24. Deal with that in a second. And then 9 minus 3k plus k minus 9 plus 12. Then here I get 12. These 18s are going to cancel. I'm left with 4k minus 24. Here the 9s cancel. Got 12 minus 2k. That is going to become, I'm just going to leave 1 over k out for the moment. Divide through by 2, 6, 2k minus 12, and 6 minus k. And finally, if I'm writing it in coordinates, it's going to be 6 over k, then 2 minus 12 over k, and 6 over k minus 1. And that is the point at which the planes will intersect. Well done.